Okay, and welcome to our first video recording session. Hopefully you've looked at and watched the introductory recording, and now this is kind of the way I'm going to pretend like I'm teaching to a regular class, and this is how I would normally be doing it, except that you'd be seeing my face, of course. These are the PowerPoints that go with our text, so I'm going to be referring to page numbers in the text as we're going along. This is what the front of your textbook should look like. This is Julia Burge's Chemistry 3rd edition, and so we're going to get started straight away. Chapter 1. Here's the list of topics in this chapter. In this first video session, I hope to finish at least, I'm going to try to make these 10 minutes to 12 minutes long because I figure that's as much as you can stand in my voice without going crazy. But we're going to get into these at least 2 to 3 topics and then shut it down, and I'll do another video and we'll go from there. The first one is just the simple definition of chemistry, which I will expect you to know. In fact, I would even add a word or two to it. It says chemistry is the study of matter. I would add to that the composition, or what matter is made of. So chemistry studies what matter is made up of, that is the atoms and molecules that make it up, and then the changes that matter undergoes. So then it talks about matters, what makes up our bodies, everything in our environment. Anything that has mass and occupies space, you've known that since very early on in your education, that matter is anything that has mass and occupies space. So you're certainly going to need to know that definition for your first quiz and your first exam. All right. Then it talks about chemistry that you may already know. Of course, I hope that you know that heat energy is a form of energy, and energy has a lot to do with chemistry. We can heat a substance up and release some energy or cause chemical reactions to occur because they have a change in energy. And then Alka-Seltzer, this is giving off effervescence or bubbling because it's releasing gas, so that's indicative of a chemical change occurring there. And then this barrel is rusting, which is a chemical change that is occurring. So this these are types of chemistry that happens in our everyday life. And then it's talking about the scientific method. And this observation that it's referring to is talking about the very first page of the textbook, which is on page 3, where it's how the scientific method helped to defeat smallpox, which is actually a very interesting story where it talks about one of the most deadly diseases that wiped out entire Indian populations in the colonial Americas, and just wiped out entire American early settler populations in early colonial America. And that is smallpox, and how it was defeated using the scientific method, which is the standard for investigating in science. And so that it begins with observations. We recognize that there's some sort of problem, in this case that's listed on page 3 of your textbook, smallpox, this terrible, terrible, deadly disease. And this very observant man in the late 18th century named Dr. Edward Jenner. And he just noticed that even though all these people were getting sick, milkmaids did not get smallpox, even though others. So he saw that there was a problem, smallpox. He made strict, very calculated and careful observations, which he recorded, and he tested them. So he made his hypothesis. I wonder why milkmaids don't get smallpox, and his hypothesis was that something in the milk, cow's milk, kept these milkmaids from contracting smallpox. And so then he made from his hypothesis, from getting cowpox, which was a different disease that gave them immunity against smallpox. And so then he tested his experiment, and would you not have hated to be the little boy, and you'll have to go back and read on these pages, in pages 3 and 4 in the textbook, the little milkmaid that he used, her name was Sarah, and the little boy's name was James Phipps. And he was the very first one that was tested. And the doctor rubbed this cowpox pus all over this child from cowpox lesions on this child, 8-year-old boy, and then he exposed him to smallpox, and indeed he did not. That was the experiment. That was the first experiment testing this hypothesis, to intentionally expose a healthy child to this deadly virus, and the boy did not contract it. So then further and further experiments were done, and eventually it led to the total eradication of this deadly disease. So, scientific method. You recognize that there's a problem. You make a series of observations. They have to be testable, and you test them through experimentation. You don't just test them one time, you test them thoroughly, and then you make your theory. And that theory doesn't just say, yes, I was right. It explains. So theories have to explain. And then you're going to retest to validate and validate and validate. And if you're wrong, then you don't just give up. You retest. Okay? And then the cycle continues. Always going to be further experimentation. Scientific method. All right. Section 1.2. The states of matter. On the states of matter is we're going to classify matter. And you know we classify lots of things. We classify people. We classify them in lots and lots of different ways. We can classify them, ranking them how pretty they are or how handsome they are. We classify them socioeconomically. We classify them, do they have book smarts? Do they have street smarts? We classify lots of things. We classify books by genre, mystery, romance, historical, fiction, nonfiction, just so many ways we classify everything. Matter is the same way. We classify matter in terms of, ultimately, we classify it as being solid, liquid, and gas. Those are the three main states of matter. There's also plasma, which we'll get to. But three main states of matter: solids, liquids, and gases. And we're going to talk about them in length. In fact, I'm going to pause just a minute and get me some. I usually write on these little squares of graph paper right here so that it halfway keeps me straight. And I'm probably digressing a little bit, but I think it is important. Matter's up at the top, and here just a few minutes ago, we talked about matter as being anything that has mass and volume. Okay? And now we're going to talk about matter being made up of these particles. Particles are either atoms or the molecules. And we know that matter is going to be either solid, a liquid, or a gas. And at the bottom of page 6 in your text, you can see that the difference in how these particles are spaced determines whether they are solid, liquid, or gas. What determines how closely those particles are spaced is how much energy those particles have. Matter that's spaced super close together, those particles don't have very much energy. Okay? So it's the energy in the particles. The energy in the particles that determines the state of matter. The particles have lots and lots of energy. They can be a gas because they have enough energy to break free from each other and move around. Particles that do not have as much gas, as much energy, they're going to be closer together, and so they're going to be in the liquid state. And if they have even less energy, they're packed tightly together, as in the bottom of page 6. And they cannot have enough energy to even move around from each other. So even though they're going to vibrate or wiggle, they do have enough energy to vibrate and wiggle, but they do not have enough energy to break away from each other. Therefore, they're stuck in their position in their line, if you will, and they cannot change their position, so they have a definite shape and a definite volume. Those are solids. So those are your three states of matter: solid, liquid, and gas. Okay? And then we also have the three classifications of matter, which we're also going to talk about. Let me get another pen here. Just a second. I'm going to make what I call the matter tree. Give me a pen. I'm about out of my time, too. I want you to know that you got matter up at the top again. And then I want you to know that matter gets broken down into being either substances or, over here, mixtures. Okay? And substances breaks down further into being elements or compounds. Let's talk about substances for just a minute. Substances are very pure. They have a definite composition, which means their amounts are going to be fixed. H2O, O2. It's never going to be anything different. You're never going to say, oh, get me some HO2. It's always going to be H2O. Always going to be the same. So you can write a formula. Since it's got a definite composition, you can be assured that if you say you have some pure water, that it's always going to be identical. It's not going to be anything different than that. Okay? Elements, because elements are the simplest type of all of the substances. We have a periodic table of those elements. So, and it lists some of them here, like iron, mercury, oxygen are these that are listed. Salt, like NaCl. See how you can write a formula for that because it's always the same. It's never going to change. H2O is water. Carbon dioxide is CO2. It's always fixed in the same exact composition, same exact ratios. And then you have mixtures, and there are two types of them also. Mixtures are either heterogeneous, and I'm just going to put hetero in here because it's shorter to write, hetero. And then you've got hetero meaning different, and then you've got homogeneous. Homogeneous means the same. Homogeneous looks the same throughout, like a glass of sweet tea with no ice, or a cup of black coffee. It looks the same from top to bottom. Heterogeneous mixtures, they look different throughout, like a salad does, or a Coke that has ice in it. You can see the ice, you can see the Coke, they look different, especially if it's got a nice foam at the top that looks different. Okay? So make sure that you have that distinction, and those are listed for you also on page 7 of your text, and you will be expected to know the difference between them. All right? That's as far as I want to go today. I will post an assignment, and I'll have you another video up shortly. Thanks.